Okay, we're going to be doing a few more story problems. We're going to use the same strategies that you've seen in the prior videos. So here's those strategies again. The one problem I'm going to do today talks about having an open box, and you can't really see the box, but here would be the base of the box, and then they've cut away these squares here. So what that does is it creates a length of 24 minus 2x, a width of 24 minus 2x, and then the height of this would be x itself. So the height is x. The way we can compute the length and the width given whatever certain height we're trying out is just by plugging in that height, because we call the height x. So we'd plug in 1, and we'd come up with the length of that and the width of the box being 12. Then we plug in 2, and that wouldn't be 12, that'd be 22, excuse me. Then we plug in 2, and we'd end up with 20 for our length and our width. So really what we have inside of here for this volume is we have 22 squared, and here I have 20 squared. So while this doesn't look like the volume, this is the height, and then this is the length times the width because of the squared part right here. So we're taking the length or the width of the side, in this case, squared, and that gives us our answer. So when I continue on with this process, and this is the long way of computing this is just doing it by hand, I get 18 for my length and my width. So my volume would be 3, the height, times 18, times 18, and I'm writing out a little bit differently. I think it looks less confusing than what I had typed in there. That ends up giving us 972. I'm going to plug in 4, and I end up getting 16. And then so I have my height is now 4 times my length and my width are 16, so 16 times 16. That ends up giving me the answer of 1,024. And then I've got 24 minus 2 times 5. And so that would give me an answer of 24 minus 10, which is 14. So I'd have 5 is my new height, times 14 times 14. And this gives me the answer of 980. And then I'd plug in 6, or I'd try 6 for my height. And I'd end up getting the answer of 12. Each time, notice my length and width are getting smaller because my height is getting larger. So I end up getting 6, my height, times my length, times my width, which ends up giving me 864. The whole point of doing this chart was to show you that you could actually figure out the maximum volume if you were talking about whole numbers and you only had to check whole numbers, and you could do that longhand. I found out the maximum value would be 1,024. Now, we could do it that way, or we can compute using the calculus problems, or the calculus method. So what I will do in the next video is show you this exact same problem using the strategy that we've talked about in this section so far.